Right. So we have seen the series object on Friday, right, which is a building block of our data frame. Now we are going to use data frame extensively. So I have taken one column. I would say in a database table, this is one column. Okay, I don't even have the column name here. Just took the series object, and there are methods like count, head, tail, mean, median, mode, standard deviation, attributes like shape, attributes like shape, okay, so now some attributes like shape, d types, right, and then we looked into the dict, right, a series object can be converted to dictionary, and then we looked at how to filter data, and then the values, the values, the index, and then value counts. Value counts is a very important method which actually gives you the value counts gives you the the what you call it as the values and their counts that will be used to generate bar graph. Okay, and now we are going to look into the data frame. I have taken simple data frame here. Okay, a data frame with 3 columns, and I am creating them. No, I am not loading it from the database or the what you call it as the CSV file. In real time, we'll be loading this data frame from file. Okay, generally file, mostly file, 90% of the times file, very rarely from database. Okay, especially while building your model, while you are doing your initial experimentation, you will definitely load it from CSV file. So 95% of the times I would say it is from CSV file. Why am I pointing out this thing is, in interviews they'll ask, how are you loading the data? You can easily say that I am loading data from CSV file and doing experimentation. Once the model is working good, then I'll connect it to the database. Whatever database, big data or small data, it doesn't matter. Okay? So here I am creating a data frame with 3 columns: student number, quiz 1 score, quiz 2 score. This quiz 1, quiz 2 stuff we have looked into in the previous class, right? That statistics class. Let me try to show you that PDF. So this student 1 score and student quiz 1 scores and quiz 2 scores, their means, the standard deviations, then variances and all that, right? We have seen. So same data, right? Whatever data I have created here, the same data is used in these, what do you call it, data frames also and series objects also. A data frame is an in-memory relational database table. When I say relational database table, there will be, the column key and values. So if you have 2 tables, right, with the same student number, you can actually join, merge, right? All those things you can do. So I have taken the table to create a data frame. We can take a dictionary. This is one way of creating data frame. We can use NumPy arrays to create data frames also. We'll see all those different approaches in coming classes, but the one way to create is a dictionary. This is a dictionary if you look at it. Why am I saying it's a dictionary? See, that is enclosed in the curly braces, again curly braces, right? And then the column name and value separated by colon. The column name and value separated by colon. The column name and value separated. A key and a value, and enclosed in the curly braces, and then the key values are separated using a colon. that is called, that is actually the data dictionary, right? So I am passing this dictionary as a parameter to this data frame class while creating the object. Pandas is a module which has got data frame class, which is taking a dictionary as an object to create data frame. Why do you want to convert a dictionary to a series object or a data frame? We have seen it in the series object. When we convert a dictionary into series object, we have got all these methods, right? To dict, right? All these methods: mean, median, mode, standard deviation. There are many other methods. I did not show all of them. It's going to be overwhelming and time taking. So I have shown only the most important methods here. So like that, when you convert your dictionary into data frame, you will get lots of free tools, right? The methods and attributes which you can use to play with. Okay, so let me run this. So in order to run this pd.data frame, you need to import them first. Import pandas as pd, import numpy as np. I have imported matplotlib, but I am going to use it indirectly, not directly. I am going to use it. This is a trouble. I need to admit one and all. The setting is not working. Okay. So I created the data frame, and then in data frame also we have got head method, which actually gives you first 5 records. Okay, there are how many records in this data frame? To know that there is a attribute called a shape. We have seen that shape in the series object, right? So there will be common attributes and common methods in both series and data frames, but there are some distinct methods and attributes also. See that shape attribute gives you 20, 3. That means 20 rows and 3 columns total. When I say the data frame head, it gives me only top 5 records. If I specify 8 here, right, it will show 8 records. So you can pass a value there, how many records you wanted to see. What is the use of head? Generally, how the columns are and how the data is, you wanted to have a feel of. Then you will use head method to look at the data. And tail is another method which actually gives you last 5 records. This series from student 1 to student 5 we got. Student 16 to 20 we got here. So student to 16 to 20 we got, right? So when the type method is from Python. If you look at this data frame is from Pandas, series is from Pandas, but this type method is from Python. You need to have the distinction, okay, which is from Python, which is from other module. Then you will be able to do that coding easily. Okay, so tail and then type. Okay, and you can actually take one column, a particular column from the data frame, and have a look at it. That can be done in multiple ways. I'll show you. So this is one way. This is data frame object. Right? Quiz df object is a data frame object. Okay. Quiz df object is a data frame object that we created here. And in that we have 3 columns: student, quiz 1, quiz 2. So the way we can access a particular column is by putting rectangular brackets and the column name. Right? You can do that. And one more way is to okay. So this is not working. Why this is not working? I'll explain in a moment. Right? This will not work basically, okay. Because so here what we did, this way it worked, right? This way it actually gave me one column, the quiz 1 column, the data belonging to the quiz 1 column. It actually gave. This is like in SQL, select a column name from the table name, right? You can actually select one particular column and look at that column data, right? That is like this. So this worked, but this did not work. I actually tried to access it using data frame name dot column name. It did not work. It will work only when there are no special characters or spaces in the column. Let me create the data frame in a different way. See, I took out the space there. I took out the special character. I took out the special character. Now I am creating the data frame again. Okay. This is all same. Okay. See this? The column space got removed. The dash got removed. The dash got removed. Now, if I wanted to access the column like that, right, it will work. When there are no special characters in the column names, you can say the data frame dot column name, and you can extract and look at it and do whatever you want. If there are special characters, right, it will not work. For that reason only, I just created the data frame with special characters. When there was like the space, right, the dash, it did not work. It threw error saying that object has no attribute quiz. It is actually thinking that it's a somebody chatted. So screen getting stuck to Mahesh. Is that happening to everybody?
Yes, Rama.
Yes.
Is that really troublesome or okay?
Okay. As you just move to another script, a while I'm getting that script a bit slow actually. So.
Okay. I actually cancelled this Zoom thing, because it is Chinese and all that. Okay, I am suffering it now. They are not allowing us to take the account now from India.
Actually, Microsoft Teams is also good. Sometimes maybe it's having some issue.
Your what?
Microsoft Teams is also good, sir. Actually, but
Yeah.
not sure. Not sure why the problem is. Already we are using in our organization, and it's really good actually.
It is, maybe I'll stop my video and see what happens. Maybe the internet bandwidth issue, maybe, right? Let us see. I stopped video.
Yeah, most probably bandwidth issue, Rama.
Yeah. So let us focus on the class, and maybe after 10 minutes again we'll see whether the same problem is happening or not. Okay. So here, when we have special characters in the column names, you cannot access the object, the data frame object dot column name. That's where it is always suggested that use this kind of syntax to access a particular column from a data frame. Whether you have special characters or not, it doesn't matter, it will work. Okay, let us try to see one more thing. I wanted to have a number in the beginning of the column. Will it work? It will work. As a data frame, it will work. But when you try to access it like this, right, it will not work again. Right, it will not work again because the two, this is kind of a variable for the Python, and it is not accepting a number, in the beginning of the variable. Okay, so it is always suggested to use the column names like that only. To access a particular column from data frame, it is always suggested to use like this only. Okay, any kind of numbering or column names, it will be able to access it. Why am I saying this is generally you load data from CSV files, and in the CSV file the data comes in different formats. And the column names and all that is not, we will not have any control over them. So it is better we take this approach to access columns so that we will not get any errors there. Got it? Any questions? Good, right? Okay, now let us see what this particular quiz df object of whatever that column name is. Okay, so I would say, this is a series object. Let us try to look at the data type of the object. Okay, this is a series object, right? So a data frame comprises of multiple series objects. Okay, this is one series, this is second series, third series, like that. When you extract, a column, right? It actually, becomes a series object. When you extract it like this only, there is one more way. I'll tell you. If you extract the column using a additional bracket like that, right? See this here? I kept the column name inside a list. Okay. This is just, let me take out this particular type thing. Don't get confused. Okay. You practice, you get it. Whatever I explain, right away practiced. On that day itself, you practice, you'll get it. These are all very important. These are all the building blocks. When I build the models on machine learning, if you don't understand or don't remember these, right, it will be like Greek and Latin. These are simple things, very simple. There is nothing big in there. Okay, so I said that you can access a column like that, right? It's a series object, I said. Now I'm putting brackets in there. Like that also you can access. So you see the structure, it changed. Do you observe? Did you observe that? Structure a little bit changed. When I accessed it only with the column name, see that it came like that, right? When I accessed it using additional rectangle brackets, the structure changed. What did it change? When we accessed with only column name, right? It's a series object, I said, right? Type of only column name, series object, right? But when I put a bracket around it, right? Structure changed. That means the type of object is also changed. See that it's a data frame. From a data frame, I actually extracted another data frame. Why do we need this syntax? If you want to extract multiple columns from the data frame, then you should definitely enclose them in brackets like this. You need to pass a list of column names to the data frame to extract. Okay, so I wanted to extract multiple columns here. Why do you want to extract multiple columns? So you do data analysis, a lot of data analysis where you actually have to play with columns. See that? I extracted 2 columns out of the 3 column data frame. And when I have to extract multiple columns, right, I should definitely put them in brackets. So if I don't have this, right, it'll throw error. Initially, when you practice, right, you will get those errors. Okay, but I am showing you so that immediately you get to mind that that's a mistake, whatever mistake you did. Okay, so like that you need to. So multiple columns, when you want to access from data frame, you should put them, you should enclose them in list. You can enclose one attribute also in list. Okay, either you do enclose a multiple columns in a list or one column in a list, the output is going to be data frame. Data type is going to be data. Why are we worried about the type of the object? Because based on the type of the object, you will have attributes and methods and access, or the control over the object. Got it? Any questions here? We created a data frame and trying to access the columns inside the data frame. Good, right? So my question now is, can I use this on a particular data frames column, can I use this value counts? Can I use this like this?
Yes.
Yes, Rama.
Why?
Because it's a series
Because
of
that is a series object.
Yeah, it's a series object. Good, right? So it's a series object, so I can use all the methods which are present in series object. How do you know what methods present? Again, you need to go to API, right? Like this. Right? I think this one is the latest one. Pandas series object. You have all the attributes, methods, right? You have you can compare two series objects, you can get argmax, argmin. What is argmax, argmin? Argmax is a method which gives you the index of the place where the value is high. You have 10 numbers in the data in the series object. In a particular place, there is a big number. You want to know the index of that big number, then that argmax method will give you. You don't need to write the code. Again, argmin also the same thing. If there is a small number, you want to know the index, it will give you. See this between. You can filter data using between method, right? Backfill. There are nulls in the series object or data frame, and you wanted to fill the null value with the value next to it. Let me try to write it down and explain. So these are all simple methods there. If you practice, right, you will get it, and no need of me explaining.
Sir,
Yeah.
can we consider series object as a single dimensional array and data frame as a multi-dimensional array,
Yes,
something like that?
yes.
That's right.
Two-dimensional
Okay.
array and one-dimensional array we can consider, but in series object also we'll have index. So
Okay.
in theory, it is not a one-dimensional array, but we can think like that. It's a column, we can say.
Okay.
When we look at NumPy arrays, right, we'll get more clarity. More clarity, or clearly we see matrices and arrays, because the NumPy arrays are used extensively, very extensively in machine learning and deep learning. Machine learning, most of it is data frames. It is enclosed in data frame and it looks easy. But in deep learning, right, the raw data frames will use. So here, this backfill, what this backfill method will do? There is a series object, right? And then there are some values here. So there is 5, 10, null, np.nan, right? np.nan is the null, and then maybe 8, maybe 9, something like that. If you call backfill, right, it will actually take this 8 and fill it here. So the whatever the value followed by, it will take and then fill it. So you can actually say data frame dot fill NA method is there, where you can specify the number there. Fill NA method will take the number whatever you give inside these brackets and fill all the null values with that number. Okay. In that, if you say method is equal to bfill, then it will work like this. Okay. So these are all different methods in there, and if you should definitely look into it. Okay. So the latest version is 1.14. I was actually looking at 0.234 yesterday or on Friday, but it is 1.14. The documentation of Pandas and what you call it as the Python is going to be very nice, very nice. Okay. So just follow through the documentation. There is lots of documentation there. There are many, size, endim, axis, values, but we have seen most of it. You look at it. Why am I saying you look at it? You come back with questions, I'll answer. If you have questions, right, you'll remember well, rather than me trying to dump everything. Okay. So that is API. How to look at API. And this value counts method I used because it's a series object. I know the data type. I know the methods present in the data type. I'm using it. Okay, so value counts actually is giving like how many 6s are there, how many 7s are there, how many 8s are there, how many 9s are there, how many 5s are there in the data frame in that particular column. Okay, series. Now the visualization. In our course, the visualization is not explained separately. We will be working on projects, we will be working on data sets. Parallelly, we will actually see how to do the graphs and charts, very what you call it as intense graphs and charts. Okay, so visualization is one part of our total project. It's not everything. Okay, in business analytics, right, they actually try to cover like around 10 days for Tableau and all that. That is not needed. As a data scientist, we'll be working mostly on the models, and for data analysis and understanding only we'll be using these graphs, not building dashboards. Okay, so dashboard building guys are separate. They do not pay 30 lakh salary to just build dashboards. Okay, AI is different, altogether different. You will see that. So I have taken this column, okay, and then I said value counts, and then there is a method called as plot and bar. This value counts method, what is the outcome of this value counts method? You need to see first. It's a series object. On a series object, there is a plot attribute. Where is that? See that? On a series object, there is a plot bar. I don't know. I clicked on it already. And you can specify the, you see that? Plot bar, H box, density, right? KDE, line. I'll talk about all these things, but no bar chart we'll understand first. Anybody waiting? So bar chart we'll talk about it first. So here the value count and then plot and bar, and I said rotate is equal to 45. If I don't say rotate, what happens? Let us see. So in this, right, I actually said plot dot x label is equal to score, y label is equal to number of students. Okay. Okay, and then I have taken y ticks. What is y ticks? The scale on the y-axis. See, I can take this is y-ticks 0, 1, 2, 3, 4, 5, 6. If I take a list of values, it works. If I take range method and say 6, it works because range method gives me values from 0 to 6. If I say numpy array has got a method called as arrange, it works. Whether you take numpy array or a range object or a list, it works. The y-axis scale we are deciding here. How many numbers it should be. If I take 10 here, right? See that? If I take 20, why am I changing these numbers? See this? These graph sizes, the bar sizes are actually becoming small because of the scale you chose. Scale is very important. On x-axis and y-axis, you always need to look at the scale while looking at the bars also. Okay? If the scale is not proper, the graph will not look that neat. It will not express the point you wanted to express. Generally, why you use the graphs and charts? You wanted to express the concept visually, right? So there are 6 students who have got 6 score, 7 students who have got 7 score, and all that you wanted to show. So that's where you are using the graph, the scale, right? Y ticks we call it as X label, Y label, and Y ticks we have used. X label we didn't scale or anything because it's a bar chart. When I say bar chart, on x-axis the values are discrete. The word discrete, I think you all know, right? Discrete means countable. I can count how many values are there. In the quiz, there are students who have got 5 score, 6 score, 7 score, 8 score, and 9 score. The score is between 0 and 10, and the students have got score between 5 and 10, right? So for each label, right, the bar chart on x-axis will have labels. Each label there is count. Each label there is count. If this is continuous, right, the values inside the column are continuous. We'll go with histogram. Okay, when histogram comes, I'll explain. Both look similar. Both look like bar chart only, but there is a bit difference. Bit difference in the way we handle x-axis. Okay, the bar quality is same, or the concept is trying to explain is same, but there will be the ranges on the x-axis. Okay, so any questions here?
Yeah, Rama, this object PLT, where we defined actually?
Yeah, that is the Matplotlib. That's a good point. Matplotlib is a module which is inspired by MATLAB. I think I don't know whether you know it or not. Generally, the AI, most of the olden days in the sense like around 5 6 years back, everybody was using MATLAB. It's a paid tool to do all the ML work. There are algorithms implemented and lots of stuff there. And R language is the next one. And Python actually tried to copy everything from the MATLAB and R and made it easy, made it open source. So now the whole community is using Python, most of them, right? Around 60, maybe 50 to 60% people are using Python. Maybe around 30% using R language and around 20% using MATLAB because MATLAB is paid. MATLAB is a powerful tool, there is no doubt, but it's a paid one. But when you compare R language and Python, right, Python is the best because Python has got modules for everything, deep learning, NLP, computer vision, you name it, there is a module. But R language has got good modules for statistical analysis. Generally, statisticians use R language. Programmers who became data scientists and AI engineers use Python because you can access the hardware, software, everything using Python. You can do all that you can do with Python, sorry, Java with Python. Okay, but one drawback with Python is it's a bit slow. When you are doing computer vision modules, you may have to switch back your code to C++. I'll show you. We are actually working on one project in the deep learning. And when we do the computer vision, right, I'll show you what we did and how much struggle we went through because of using Python and not using C++. So this is Matplotlib, which is a module which actually does all the graphs and charts visualization. There will be one more module I'm going to introduce to you is Seaborn, which is a wrapper on top of this Matplotlib, which actually works very nicely with different easy methods to do plots. Okay.
Yeah.
So PLT is an alias for Matplotlib's PyPlot. PyPlot is the actual package, I would say. This is a module and then it's a package. In that we have all these bar, the X ticks, Y ticks, and even the plot, bar, histogram, all these are from Matplotlib only. Inside this series object, they implemented, they actually call the Matplotlib only internally. Okay,
So
there is
I have
internal
one more doubt,
dependency.
like how this access AX1 object will we are not using any AXL1 object in this PLT with the PLT object, right? So how it is related?
AX, axis object we'll use later. We are going to do subplots. Subplots in the sense in one diagram, you are going to generate multiple plots. Okay.
So my question is how this first line will connect with below 3 lines.
It is actually even when you are not using this PLT module will actually try to map it to the object which is available currently. Current cell has got it. Okay, it is internal. Okay, no need to connect. It is like you're asking, like a variable I declared and I'm trying to use that variable in other places. Yes. It is connected. I can understand, but here it is not connected. But how it is internally knows that the current plot is what we are actually trying to infer to, and we will specifically also use it. This object will use it in future. I'll show you. Maybe at the end of the class, right? After stopping recording, I'll show you. There are some projects we are working on. I'll show you.
Yeah.
Just
Rama, that means like in the below, if you are creating another flat X label and Y label for the quiz2, it will bind to quiz2?
No, when you have two plots in the same thing, right? We need to use subplots. I'll show you.
Okay.
I'll show you. Okay. So if you take out that variable, right, what happens is it uses to show. Right, let me try to take out this one also. Object name it uses to show. That's where I think it is not showing. See this here. This is actually showing object name, right? If I put variable name there, right? If I put variable name, that object name will be engulfed by that variable and you will not see that object. That's where I just kept that variable name. Okay. Right? Got it?
Rama, one more thing. The score, where is that defined? We are using score, right? Is it in the data frame?
Yeah, it is in the data frame. The quiz one is the score column only. Quiz one is let me show you that head of the data frame. That's a good question. Right here, what is the student hash? Student number or student name? Right. Quiz one is the score in the quiz one participation. Quiz two is the score in the quiz two participation. Got it? The column names can be anything, but when you are visualizing it, it should be business point of view, right? The business people should understand. Got it? In database table, your column names can be anything, but while visualizing it, you should have a meaningful, human readable name, right? Right. So
looks like it is just assigning a label to the access name, right?
that's it. Okay. Right, I can put it like this also. Quiz one score. Right, see that quiz one score. If I'm doing right this second quiz, right, quiz two score I will be putting.
Yeah.
Okay, so these visualizations are very important because in two ways. One, to understand data and clean up the data. Second, we will make decisions. We may try to remove. We may actually make a decision on removing a column, or we may make a decision on replacing some nulls with some value. But there should be a reason. There should be a justification, right? So these graphs will help us in justifying. Why do I need to justify, and whom do I need to justify? To the team before we move it to production. There will be peer review. Peer review in data science projects is not to pinpoint others. It is just to come up with new ideas. Because when you are executing data science project, right, it is not like this is it. There is no way that you can say only one way to clean the data. There will be multiple ways. But which one is the best we need to choose. So sometimes we may get some idea, sometimes the teammate may get some other idea. So when you show them all the processes or all the approaches you took while cleaning the data and reach to a place, the other people will also are thinking, right? They'll actually suggest maybe we should go this way, this route also should be tried, right? Like that. So that those peer reviews and client reviews, we should be having these graphs and charts so that we can justify our decisions. Got it? This is now you build a model, you get 90% accuracy. Client will say, no, I want to get 99%. I don't like this model. You should actually convince the client that this is the best we can do. Got it? Got it? What the point I'm trying to say? Did you guys get it? It is not always possible to get 99% or 100% accuracy on a prediction. Right?
Yes.
Yeah, it's a prediction, right? It's a prediction. So you should be justifying that this is the maximum we can do, or best of all the maximum, best of all, right? Maybe there are 10 best. This is one of the best, right? So to justify also it is useful. And the quiz 2 also, right? I can say the quiz 2 score, right? And on the scale, Y scale, you can actually decide. I actually took it is the looking 6 numbers I wanted to. If you want to compare let me try to reduce the size of the screen a little bit so that you can see both. I can put both in one graph. I will do that in a moment. Right? So if you want to compare these two quizzes, right? If I take like that, maybe I'll take even less. It looks like if you don't look at the X scale and Y scale and look at the bars, it looks like almost similar. Do you agree? Almost. Not everything, but almost. Do you agree?
Yeah.
Right? Because of the scale, it is actually working like that. It is actually looking like that. When you want to compare two graphs, right? The scale should be same. The scale should be same or similar, especially the Y scale, right? In this particular scenario, the Y scale, we are looking at how many people have got 6 score, right? In here, 5 people have got 4 score, but it looks like the bar height is same. So if you take the scale same. Here also 6 numbers. When I say a range of 7, right, that is 6 numbers only. Let me try to copy this and put it here. Right? Scale is same. Do you agree? 0 to 6, 0 to 6. Now it looks like, no, it actually, you can compare. You can compare these two graphs. No, first graph has got, more people around 6. Second graph has got, the people are there around 4, but the score is 5 only, right? And the second graph, the data is different. First graph, the data is different, even though the means are same. If you look at this whatever presentation, right, means are same, but you don't know, you don't have a clue that how the students are performing. When you look at these graphs, which the same scale, then you will understand. With same scale, you will understand that the data is different, the performance of the students is different, and then you can understand how it is exactly working and all that. Okay, so let me try to resize. So you understood the importance of scale, right? Any questions there? Now the screen is working good. Is it still getting stuck, or is it good?
No, it's good now.
So maybe because of the video, maybe the problem, right?
Yeah.
Maybe my internet is slow. Maybe I need to look at that also. I look into that. Maybe I need to reboot that. Tomorrow we'll again check with the video. Okay. And now the box plot. What is box plot? We have seen this interquartile range, right? I actually showed you interquartile range. What is interquartile range? There is quartile 2, which is the median. Quartile 1 is the first half, median of the first half, and quartile 3 is the median of the second half. Why do you need quartiles? Because you wanted to see whether there are any outliers in the data or not. What are outliers? The data entered into the data set by mistake. Maybe the data entry operator's mistake, or there are some devices which are actually dumping data. Nowadays, we see many IoT devices in attached to computers and all the devices, right? You will see in next 2-3 years, right, many IoT devices which are intelligently working. That means you will be seeing robots inside your home. Robo doesn't mean it looks like a toy human being and walking around and all that. It can have wheels and walk around, or it can actually stay there as a camera on the wall and it can work. Everything which is intelligent in nature can be called as robo. Okay, so those devices are got corrupted and then they are dumping data into the database, and you are taking that data to make the model. The model may get wrong patterns, so you need to understand which data is right and which data is wrong and clean it up. So to do that, interquartile range is a method. Interquartile range is a way to get a clue on which one is right, which one is wrong. So if you have million numbers, right, you cannot actually look at it like this. You definitely need to draw a graph like this. So this is called a box whisker plot.
Sir, so the purpose of interquartile is to find only the outliers.
Yeah, generally the purpose is to find out whether there are any outliers in the data.
So that means in every analysis we need to perform this interquartile to come up
Yes,
with the
madam.
outliers.
Yes, madam. Maximum we'll use bar graphs, histograms, and the box whisker plots while doing data analysis. We look at means, medians, modes, and the interquartile ranges and all that. I'll show one more method here. I forgot to write it here. I'll show one more method. Yeah, here it is, the describe method. Okay, so these are all things we definitely have to look into. Okay, so here if you look at this interquartile range method works with numbers only because it is mean, median. So median, first half median, second half median, right? So it works with numbers only. So the box plot is a method which is present on the data frame. If you have to write a graph like this, right, you have to write lots of code. Because of using data frame, you have got that flexibility. Just calling a method will actually give you a good plot like this. And on which columns you wanted to do that, I am passing those column names. And when I press enter, right, It's clearly showing that, the box-Fisker plot. What is this middle line? Is the median. Okay, this middle line is the median. This line is a quartile 3. This line is quartile 1. Again here also, this is quartile 1. This is quartile 3. This is median. In this data, mean, median, mode are same. That's where we have got the 7 as the center number. But in general, in other data sets, right, the boxes will be, in a little scattered way. And then this is minimum.
Sir,
This is
how
max.
to identify mean, median, mode or same from this graph?
See, the 7 is there, and you see the green line here are aligned, right? They are actually in line with 7, right?
Okay.
So median and mean we know because we already looked at it while looking at the analysis here, right? The mean is same, right? And then median is like this, and I know mode is also same on this data set. So we have to actually call the methods and see whether they are same or not. But in these two data sets, right, median is same, right? I can see by looking at the graph, I can see that here. Got it? I think, no, I looked at it already and I spoke, right? But here, when you look at these graphs, the median is same. You can see that clearly. Is that answered your question or?
Yes, sir.
No. And then, this line and this line are the minimum and maximum. Minimum and maximum. There will be data points beyond this also. If there are data points beyond this minimum and maximum, right, then you will get most probable outliers, right? You will get dots. They get as dots. We'll see that in data sets. Okay, when you actually take a data set and take a column and try to do box-Fisker plot, there will be some dots beyond this line and this line. They are most probably the outliers. So you need to actually get into the data set and see those data points and see whether they're outliers or not. Sometimes, even though data is valid, the graph may show it as outlier because graph doesn't know. Graph just knows the mathematics, right? So how does it calculate the outliers? 1.5 into quartile 3 are all outliers. 1.5 into 5 into quartile 1 minus actually are all outliers. The numbers below that number, if the quartile 3 is 30, 1.5 quartile 3 is 45. Beyond 45, if there are numbers, it will actually put them as dots here. Visually, even though there are million numbers, billion numbers, you can see visually whether they are outliers or not. Numerically outliers, statistically outliers. Business point of view, they may not be outliers. I gave one example. In Hyderabad, if you look at the house prices of Banjara Hills and Jubilee Hills, they look completely outlier kind of thing. They'll be in crores, 30 crores, 40 crores like that. But if you look at other cities data, it will be like in lakhs. But if you try to do a plot, right, they actually box-Fisker plot. The box-Fisker plot may show it as outliers. Okay, but in reality, they are not outliers. So you may have to build a separate model for that. Somebody enter now. Okay, so this is box-Fisker plot. So this is called as box plot also. Any questions? Right? Now you can create a column in a data frame. In database tables, right? If you want to create a column, you should be doing alter table and table name, and then the column name and the data type. If it is a primary key or foreign key or whatever key, you need to specify all that and press enter. Then it will create because it is on the hard disk in a file. Here everything is in memory, and these guys actually made it easy. So if you take a data frame and say the column name and then give the values in a list. This is a list of all the college names. Okay, the college name. So there are two colleges, St. Mary's and Xavier. St. Mary's and St. Xavier. So I gave those in a list. You can give them in a list or an array. It takes. If the column is already existing, right, it will overwrite it. If the column is not existing, it will create it. Like in dictionary. In dictionaries also, if you have the key, it will override the value. If you don't have key, it will actually create the new item in the dictionary. Like that, in data frames, if the column is already there, it's going to overwrite. If the column is not there, it will create. See that we have got a new column there. Okay, and then if you, I actually dropped one column here. There is a method called as drop, which actually drops a column. And then if you look at this drop method syntax, the parameters it takes the column name, and then there is a new attribute called as axis. What is this? We don't know. And in place true also we don't know, right? If I take out these two, what happens? Let us see. See that it is throwing error saying that student hash not found in axis. What is axis? The rows and columns. Okay, on a data frame, the vertical, the horizontal thing, right? And y-axis means the vertical thing, right? The same similarly on a data frame also. Let me try to take a screenshot here. On a data frame also there are two axes. What is, axis 0? Axis 0 means rows. Okay. Axis 1 means columns. Okay. So the error thrown is actually saying that couldn't find this particular name in axis. What is the default axis? We need to see. Default axis is going to be 0. Okay. I said in a data frame there will be two axes, 0 axis and 1 axis, right? So by default the axis is going to be 0. So in 0 axis, if you try to see 0 axis, the indexes are 0, 1, 2, 3, 4. There is no student hash in 0 axis. That's what the error actually is trying to explain. There is no student 1 column or the heading in 0 axis. Either it is index in the row or in the heading in the column. It is actually indexed. So it is actually trying to find the student number in this axis, 0 axis, and it couldn't find it. So let us try to put that axis equal to 1 there, and it works. I'm taking in place true. See that it actually removed. Right? Originally what we have, there is an attribute called as columns dot columns. Originally we have student number, quiz 1, quiz 2, college. 4 columns were there. But when I actually dropped and said axis 1, the error is gone because it is looking into the column names now, and it found the student number in the column names and it dropped it and showing. It is just showing. When you don't have in place true, it will just column and show it looks like. Removed it. If it is showing the output, it is not performing the activity on the data frame. What is our intention here? Need to remove this column, right? When I said remove, drop the column name and access is equal to 1, it showed me the output. When I kept the in place true, the output is not there. That means physically it removed. If I execute this again, right, it will throw error saying that the student number is not present in the data frame. See that? Because it removed it. It physically removed the column when I had in place true. In place true is an attribute that actually physically removes a column name from the data frame. This in place true method attribute is present in many other functions also. Okay, none are above. And then if you see columns you have, and then if I say in place true, it works. Got it? Any questions here? Any questions? Okay, good. So in place true you understood, drop method you understood, and columns is an attribute which actually gives, right? Now the column student number is removed. Now if I say on a data frame, mean method is there. On series object we have seen mean method, right? Mean, mode and median. On a data frame also we have mean method. When I say mean, right, it is going to calculate mean for numerical columns only. See this column, no, college is a string column or categorical column. It did not do anything, on that, and it did not throw any error also, right? Describe is a very important method which actually gives you all statistical measures, all statistic metrics in a single shot, right? Data frame.describe is actually showing me on quiz 1 how many non-null values are there. How many non-null values are there? 20 values are there which are non-null in this column. 20 values are there which are non-null in this column. Mean is 7 in this column. Mean is 7. Standard deviation is 1.25. Standard deviation is 2.026. Minimum is 5. Minimum is 4. This is quartile 1. This is quartile 2. This is quartile 3. Maximum. In a single shot, you are getting most of the descriptive statistical metrics. What is the use of it? If you have some nulls, right, you will know here, right? If standard deviation is too high, then you will know that the variance is too high. If standard deviation is 0, you can eliminate that column itself. If the standard deviation is 0, that means the column is not at all useful. Okay? Why is it so? If the standard deviation is 0, I am saying column is not useful. Why is it so? Anybody?
Because all values are same.
Yeah, I think I already explained that, but I'm just checking whether you are focusing or not. If all values are same, that column will not be able to predict the y values. It is, I generally take this example. You took me as an advisor, right? Generally in governments, there will be advisors like me only, right? They'll go there and say whatever chief minister says, he says yes. No, never saying no. It is all yes, right? What is it going to happen next election? The guy is not going to win because he took suggestions from a person who always says yes. Who always says yes means if you try to capture all the decisions in a database table, the suggestions given by this person is all going to be yes. Variance 0. Variance 0 means prediction went wrong and result came wrong, right? Like that it is. Okay, if in a given data frame, if a particular column's variance is close to 0 or 0, that column is not useful in making predictions. So you can eliminate that column. So easily you can see, if you do describe, right, most of the numerical columns attributes you can actually understand at a high level. So you are getting the gist of it, right? By using these mathematical concepts, so we are actually trying to understand data, right? Business, or whether to keep the column or not, how to replace the values and all that we are understanding, right? So that is the key. That's the key. So mathematics separately can be understood, business separately can be understood, but we should mix both and try to use it here. That's the beginning of data science. Okay, and then there is a size, there is a group by method. Do you guys know group by in database tables, SQL queries? Anybody?
Yes, Ravi.
Right, you know that, right? The same thing here also, right? In this particular data frame, there are students belonging to St. Mary's College and St. Xavier's College. If I want to group by college and look at the count, this is how you need to do. Data frame, group by the column name, and then say size. There are 10 students belonging to St. Xavier. There are 10 students belonging to St. Mary's. Okay. Now, if I want to see, just what's happening when I say group by only, it is actually showing a object there, right? To clearly see what is exactly present in there, we can actually take the group by object, iterate through and see. For key and group in the group by object and trying to print the key and the group. See that I printed the key, that is the Saint Xavier's group. No, I just take out this whole junk here. You'll be able to understand that clearly. Key is Saint Xavier's. All the students belonging to that particular college and the quiz course, right? All the students belonging to that particular college and quiz course. We are actually kind of, separating, distinguishing between the students belonging to one college and another college, and we can see clearly the, scores there. In our data sets also, you'll have these kinds of scenarios. Okay, so I just try to beautify it by using that. Those. Any questions here?
Sir, then what is the difference between the group by and count values?
Count values is general, it is actually counting whether nulls are there or not. If there are nulls, right, it is going to give less number. Even though 20 rows are there, if three are nulls, it will give 17 only count.
Okay. Here also, if there is a nulls, then it will not come under the group by, right?
It will come. The null is actually present in the quiz. Let us try to induce that null in there in one of the quizzes and then try to run this and see what happens. Okay.
Okay.
So, here I am putting null np.nam. That's a good question. Right. Here also I am going to put np.na. Okay. And then I'm going to run this again. This in this quiz this describe method, it actually gave me only 18 because 2 are nulls. Okay, if you look at the group by, right, there are 10 records belonging to Saint Xavier and Saint Mary's. It doesn't matter whether it is null or not, there is, right, there is a row both. Right here, if you see, it is showing that 18 quiz 1 18, but if you see here, and one of the person belong to those null guy, one person belong to Saint Xavier, another person belong to Saint Mary's. Distinguishing between groups. Got it?
Okay. Okay. Got it.
So yeah, play with it, I would say.
Yeah. I will play.
So let me try to, because I have to upload this file there. So kernel restart. If you restart kernel, right, the numbering will change. It's like freshly loaded file. Okay, now shall we continue this class or shall we take it tomorrow? Can you guys take it?
You take it tomorrow, Ram, because a lot of stuff we need to look into that today.
Yeah. So good. Okay, I said I am going to show something, right? Give me 1 second. Let me stop recording and then I'll show you